Welcome to this beginner's guide to quantum computing. In this video, we'll explore what quantum computers are, how they're different from the computers we use every day, and why everyone's talking about them. Don't worry, I'll keep things super simple, and by the end, you'll have a strong understanding of how quantum computing works. So let's begin our quantum journey. Here's what we'll cover today. We'll start by understanding what quantum computing really is, then compare it with traditional computing. After that, we'll explore the weird but amazing concepts like superposition and entanglement. We'll also look at how quantum computers are built, how they run, what they can do, the challenges they face, and where things are headed in the future. Quantum computing is a completely different way of processing information. Regular computers, like your phone or laptop, use bits, which are like tiny switches that can be either on or off. That's 1 or 0. But quantum computers use qubits, which follow the strange rules of quantum physics. These rules allow qubits to be in more than one state at once. Because of this, quantum computers can process certain problems much faster than normal computers. Let's compare regular bits with quantum bits, or qubits. In a traditional computer, a bit can only be 0 or 1, like a light switch that's either on or off. But a qubit can be both 0 and 1 at the same time. This is called superposition. A good example is a spinning coin. While it's in the air, it's kind of both heads and tails. That's what makes qubits so powerful. They can handle more information at once. There are three key ideas that quantum computing is built on. First is superposition, which means a qubit can exist in more than one state at the same time. Second is entanglement. When two qubits become linked, the state of one instantly affects the other, even if they're far apart. Third is interference. Quantum computers use this to boost the chances of getting the correct answer and cancel out the wrong ones. These three principles allow quantum computers to work in ways that seem impossible with regular computers. A qubit is short for quantum bit, and it's the smallest unit of information in a quantum computer. Unlike regular bits, qubits can be made using different types of particles like atoms, electrons, or photons. These particles are controlled in a lab using magnets, lasers, or electric fields. What makes them special is that they follow quantum rules, meaning they can be in multiple states, become entangled, and even affect each other instantly. There are several ways to create a qubit. One method is superconducting qubits, used by IBM and Google. These are circuits cooled to nearly absolute zero. Another is ion traps, where atoms are suspended and controlled using lasers. And then there are photonic qubits, which use particles of light. Each method has its strengths and weaknesses, and scientists are still trying to figure out the best way to scale up quantum computers using these technologies. Quantum computers work in a few steps. First, they initialize the qubits to a known state, usually 0. Next, they apply quantum gates. These are like instructions that change the qubits. Then the qubits become entangled and interact with each other. Finally, we measure the result, which collapses the qubits to either 0 or 1. This process gives us the answer to the problem we're trying to solve. But because qubits are probabilistic, we often repeat the process many times to get reliable results. In classical computers, we use logic gates like and, or, and not. They take fixed inputs and produce fixed outputs. Quantum gates are different. They're reversible and often involve rotating qubits to change their probability. For example, the Hadamard gate, or H gate, puts a qubit into superposition. The CNOT gate entangles two qubits. These gates are used to build complex quantum circuits. So, what can quantum computers actually do? They're especially good at solving problems that involve massive combinations or patterns. For example, they could one day break encryption by factoring huge numbers quickly. They can simulate molecules, which helps with drug discovery and chemistry. They can also optimize logistics, like the fastest delivery routes. And they might help improve AI by finding patterns that are too complex for normal computers. Quantum computing is still in its early stages, and there are big challenges. Decoherence means that qubits lose their quantum state very quickly. Noise from the environment causes errors in calculations. It's also very hard to scale. Building a quantum computer with many stable qubits is a big task. That's why researchers are working on quantum error correction, which is like fixing the mistakes qubits make, but it's very complex. Quantum algorithms are special instructions made for quantum computers. Shor's algorithm is famous because it can factor large numbers fast, which could break today's encryption. Grover's algorithm helps search large databases more quickly, kind of like finding a needle in a haystack much faster. These algorithms show how quantum computing can solve certain problems better than any classical computer. You don't need a quantum lab to get started. You can write and test quantum programs using cloud platforms. Qiskit by IBM is very popular and works with Python. Cirq is made by Google, and Breakit is Amazon's platform. You can use these tools to write code, build quantum circuits, and even run them on real quantum computers available online. Today's quantum computers are still small and noisy. We call this the NSQ era. That stands for Noisy Intermediate Scale Quantum. Companies like IBM, Google, Rigetti, and D-Wave have working machines. You can even try IBM's quantum computer online using Qiskit. It's a great time to start learning because you can experiment without needing any hardware. The future of quantum computing is exciting. We might see hybrid systems where quantum and classical computers work together. We'll have stronger encryption techniques built to resist quantum attacks. We'll discover new drugs and materials faster using quantum simulations. And AI could become more powerful by using quantum algorithms to learn and make decisions more efficiently. Let's quickly recap. Quantum computing is not just a faster version of normal computing. It's something completely different. It uses qubits, which can be in multiple states at once. It's based on principles like superposition and entanglement. And while there are still challenges, the potential is huge, from improving medicine to reshaping AI. Thanks so much for watching. If you enjoyed this video, please give it a thumbs up and subscribe to the channel for more beginner-friendly tech content. Got questions about quantum computing or want a deeper dive into something? Let me know in the comments. I'd love to hear your feedback and suggestions for future videos.